Hello, good afternoon. Wait. Hello, students.
Hello, sir.
Another day, the audio and this thing not going.
Afternoon, sir.
Good afternoon. Hold on a second, guys. Testing. All right, I want to get rid of this thing. All right, good. All right, I got it. No, I got it. All right, good afternoon, guys. Good afternoon. But I can see the screen, hear me well?
Yes,
All
sir.
right, good. I had to put that problem a while ago with the audio. I think I have it okay now. All right, so this is the paper I sent you yesterday. Well, today actually. I was supposed to actually send it from yesterday. It's the time of the season. You have to bear with me. Still gonna do the work. Hope you had a chance to do some of the questions. Any of you did any of the questions?
Yes, sir.
All right, good. Remember, even if you did not do the questions, once you're prepared to do them, even after this session, that is still good enough. Still good enough for me at this stage, all right? What is this? Got it. Right, we can draw graphs now. All right, so I'm starting with this. This is the January 2015. And syllabus are a little bit different. Well, maybe just the structure of the paper a little bit different back then as compared to now, but questions are still very much relevant. So we're gonna just practice some questions. This is a revision thing. All right, we're gonna start at number 1. All right, if you notice, I'm leaving the calculator on the screen over here because number 1 is always a calculator question. See? Use a calculator otherwise, and they want the exact value of this. So again, because they tell us to use a calculator, it's a matter of typing this in the calculator exactly as it is. I'm just going to type it in there and then put equal. So it's 12.5 squared minus bracket 30 divided by 0.375, close bracket. I'm getting 123.84. I'm going to look at this thing up here to ensure that it matches this thing perfectly, which it does. All right, just that there is no bracket around this on the calculator, but it doesn't matter. But put a bracket around it. If you see, there's a bracket now. So it's really the same thing. All right, the answer is 123.84. Because it said exactly, you don't make any correction. You give exactly what the calculator gave you. That's an exact answer because it's a decimal, but it terminates. When it terminates, it's an exact value. This can be expressed as a fraction, guys. And we can see what the fraction is. Any fraction that terminates, any decimal that terminates can be written as a fraction. That's it, right there. Any decimal, any number in decimal form that terminates, or if the values, the decimal place values repeat, it can be expressed as a fraction. All right, because then it is what we call a rational number. A rational number can be expressed as a fraction with a integer numerator and denominator. All right, so that is it. Anyway, this is the exact answer right there. All right, 1 mark for that, I'm sure. Yeah, 3 marks. Wow, wonder why it's 3 marks. Since it's 3 marks, I would go back and show some work, work out this part and this part separately, just because it's 3 marks. And I fail to believe they're giving 3 marks just to work this out. So just because it's 3 marks, I'm going to work it out step by step. Just because it is 3 marks. All right? That's the only reason. So I'm going to work out this part of it. See what it is. I don't think it makes any sense, but it's 3 marks. So let me show some work. So it's 12.8 squared. The exact value of that is 163.84. Hold on, somebody calling me. Hold on a second. Let me see. Somebody's calling. So what this is. Okay, I'll take that call now. And then now I'm subtracting, and then you have to do the division or the bracket term by itself. All right, so I'm gonna do that part, which is 30 divided by 0.375. That will be 80. And if I work this out now, since I give him 3 marks, let's show some work. 163.84 minus 80. And we get, so why am I getting the same answer? You see that? You see that? You see that?
Sir, that's what I got, sir.
Nah.
That's what I got.
What a thing this now. Let me put it back in the calculator straight and see what happens. Wow. Let's put it back in the calculator straight again and see. So I'm going to put back the 12.8 squared and square it. Because maybe this question is testing our knowledge of using the BODMAS system. All right, and we're going to square that. And 2 times square it. It's 163.84, right? Then if I work out that bracketed term, which is 30 divided by 0.375, I'm getting 80. And so we're learning something from this, If we work that out and work that out separately, but why is the calculator not giving us the correct answer if we type it in exactly as it is?
Sir.
Yeah.
Sir, what had happened before was you had everything, but when you reach the 30 divided by the 0.375, you had 0.75.
Oh, all right.
Yeah.
The wrong thing. Okay.
Yes, sir.
Okay. All right. Okay. Okay. So you're saying the correct, I had the wrong thing here on my calculator. I was saying to check it and still made a mistake. So you see, that shows the importance of ensuring that you type this in correctly. So even while I was saying check it and make sure, I still had the wrong thing. squared minus bracket 30 divided by 0.375. Okay, so this is the answer now. 83.84. So I almost gave it away. Good thing I decided to check it, and do it the other way. All right, so you should have said something, man. If you say I typed the wrong thing, we're in this together, you know. If you say I typed the wrong thing, and the person who got a different answer from me here should have said something as well. Don't just be there and accept everything. I can make mistakes as well. I typed the wrong thing here in the calculator. So it shows, this example shows that is very important that you know what you type in the calculator. You type it exactly as it is there. If you make one minor change, the answer is going to be wrong. Any change, anything different, the answer is going to be wrong, as you saw in the example, in this example. All right, so use this. This is a good learning opportunity for us. Well, I'm not the one doing the exam, you know. You are doing the exam. All right, so that is the correct answer. All right, so thankfully we have the right answer here now. Good thing I decided, good thing the 3 marks here led me to go step by step. All right, so that is that. Let's continue. I think the next part wants us to do some correction. No, that's it. All right, that's it. Spend a lot of time on that one.
Sir, see this
Okay.
question, sir. I saw this question on my maths paper that I got, sir. I
Yeah,
didn't know
one.
what to do.
Which one? This one?
Yes, sir.
Okay. All right. Let's see. It says 3/8. It says Mark spends 3/8 of his monthly salary. So like he divides his salary by 8, and he has 3 parts of it that is going towards his income. Going towards housing, right? So he has 5/8 left. 5/8 of his salary is left. If he spends 3/8 over here, he's gonna have 5/8 left. Let's see what this says. It says of the remainder. Remember, the remainder now is 5/8 of his salary. 5/8 of his salary. He spends 1/3. So it's 1/3 of 5/8 of his salary on food, and then he saves what is left. He saves what is left. All right. So what is left? All right. So look at it. 3/8 gone towards housing. All right. It says calculate a fraction of amount is spent on food. But I'm going to break it down before we answer this question. I'm just going to show you something. So 3/8 is spent on housing. How much does he have left? He has 5/8 left. 5/8 he has left. This is the amount he has left after he spends on housing. Of this 5/8, he's spending 1/3 of the 5/8 on food. That goes towards food. What does work out to? Let's write what this works out to. This works out to 5/24. This is a fraction that he spends on food. If he spends 1/3 of the 5/8, then he has another 2/3 of the 5/8. And he saves the rest. Let's read it again. He spends 1/3 on food. It says of the remainder. Remember, the remainder is 5/8, right? That's remainder. And put remainder right here instead of left. This is the remainder. He has 5/8 of his salary left, working in the fractions. Of this 5/8 of his salary, he's spending 1/3 of that 5/8 on food. 1/3 of 5/8 is 5/24. And then if he spends 1/3 of this total, he still has 2/3 of this total left. 2/3 of that. This is it. All right. So that's what he spends 1/3 on food and saves what is left. So this is what is left. So this is now 10/24, and that goes towards food. You see this 3/8, if we were to express it as a fraction over 24, we'll multiply this by 3 and multiply this by 3. So this 3/8 is the same as 9 over 24. So 9 over 24 going to housing. Why am I doing that 9 over 24? Just to bring everything over 24. Right? And then if we add up all these parts now, 9, 5, and 10, supposed to give you 24 because that represents the whole salary. 9 plus 5 plus 10. See, 24. So we have covered for the entire salary. 9 over 24 on housing, 5 over 24 on food, 10 over 20. Sorry, this is what is left. The last one is what is left. What is saved. My mistake, saved. So these are the fractions. This is 9 over 24 went to housing. 5 over 24 went to food. 10 over 24 went to savings. If you add up all of this, you get 24 over 24, which is one salary, is entire salary. So I just did this breakdown to show you. That's how it can maybe interpreted. Those are the parts. So since these are the parts of his salary, you can answer any question. What do they want to know? They want to know here, calculate what fraction of his salary is spent on food. See here? This is the answer for this part. Food. This is the food answer. So the answer for this question is right here. Answer. Fraction is 5 over 24. It says, calculate the fraction of his monthly income that is saved. See here? 10 over 24 is saved. If you want to simplify it, you can divide it through by 2. Divide it by 2 and it's by 2. And it becomes 5 over 12 is saved. But understand that? But good with that?
Yes, sir.
Yes, sir.
Yes, sir.
All right. So
Yes, sir.
if it's 5 8, if you take out 3 8, you have 5 8 left. This is the amount that was left after they took out 3 8s. And then 1/3 of the 5 8s. You just multiply them. And then you're gonna have 2/3 of the 5 8s left after you take out this 1/3. And that represents all the parts. That represents all the parts of this salary. And so that's a nice way to break it down. Nice and easy, quick and fast. All right. All right. So I can move on, right? Everybody comfortable with this?
Yes, sir.
All right, good. Let's continue. So this one now is a exchange rate. I think I might need a calculator. Maybe about a calculator for this one. So I always say to students, do exchange rate questions as ratio questions. It's like kind of easy because ratio questions, you can do ratios by simply multiplying and dividing by constant values or constant units to get the information you want. And you can do exchange rate questions that way. Because that's a nice way to do ratio questions. Just multiply the values up and down to get the actuals. You multiply them up until you have the actual values in the ratio. All right. All right. So remember, you know, ratio is just a simplified form of the proportion of quantities. You know, that's what it is. You know, the proportion of quantities, and you break them down into low terms. So, for example, if you have 15 things total, and you take 5 of it to do something and 10 of it to do something else, they are broken down the 15 into a ratio of 5 to 10. But this ratio of 5 to 10 can be simplified 1 to 2. 1 to 2. And so the question might give you this as the ratio of our 15 things are shared. It will give you this, 1 to 2. But then this 1 to 2, right? Let me show you something now. Since you know, look at this now. Since you know that this 15 is broken down in ratio of 5 to 10, this is the first part. Let's call it first part. Let's call this first part. Let's call this second part of the ratio. Second. But I can put in another part for the total of the ratio. Total is 15. So if the question might give you this information, I can put in a section for the total parts in the ratio. The total parts in the ratio here would be 3. And so if I know that my actual total is 15 and they give me this, I want the total part to go back up to 15. So then I would multiply this ratio by 5 because I want this to become 15. I want this to go back to 15. And you realize then, if you multiply by 5, the total goes to 15, the 2 goes to 10, and the 1 goes to 5. So because the actual total is 15, it means that this is the actual first part and this is the actual second part. And that's how ratio can be done. Nice and easy. But let me get to this question. All right, this was just like me digressing a little bit. All right. So we're gonna do the exchange rate as a ratio question. Do it as a ratio because the ratio is US to Barbados dollars. That's what this is. They say at Bank A, US $1 is for Barbados 196. The BD means Barbados. It says calculate the value of 700 US dollars in Barbados dollars. So like we have the one side I want to become 700. Let me set it out. This one easy now. You know, there's a multiplier by 700 and you're good, but let me show you if you're doing it as a ratio. So like I set it out, US to Barbados, BD, right? And they're telling us here that the BD means Barbados dollars, right? And it is 1 to 196, 1.96. I will know that we're talking in dollars. We know we're talking in dollars. So I don't have to put the dollar sign here and here. So my ratio is 1 to 1.96. And I want to know what 700 US is equivalent to. Then I need this side to become 700. So what do? I simply multiply the ratio by a value that will make this side become 700. Obviously, that's 700. So when I multiply the ratio by 700, the US side becomes 700, which is what I'm trying to find out. The equivalent Barbados dollars for. So it means that I multiply this side by the 700. I get 700 US dollars. 2, and I multiply this side by the 700 as well. And so it is 700 times 1.96. So that's 1372. So I can write the answer now. That is Barbados dollars 1372. This is my answer to the question. 700 US dollars is this Barbados dollar. Now this was easy question. I know that I just need to multiply by 700, but I'm trying to show you the approach if you do it as a ratio question. That's why I did it that way. All right, just to show you the approach as a ratio. If you do it as a ratio, I'm going to continue doing it like that until I get a good feel of that approach. Down here now, it says Bank B, the 700 US dollars is this amount. So if you notice, it is more than that. What they want us to calculate is what is 1 US dollars in Bank B. So we're going to write back this now as a ratio. And this time we want the US side to come down to $1. So it's now a matter of dividing by the 700. So let's set up again. So at Bank B, at Bank B, US to Barbados dollars is 700 to this amount, 1386. So actually getting more money for your 700 at Bank B, right? We want to know what 1 US is. So we need the US side to go down to 1. So if it is at 700 and want to become 1, what you do? You divide by 700. Divide the ratio by 700 because you want the US side to come down to 1 so that you can see what this side is. So when you divide this by 700, it becomes 1. This side becomes 1. 2, I'm going to divide this now by 700 on the calculator, which is 1386 divided by 700. And that is 1.98. So the answer for this question, I can say, i.e., it is Barbados. I can write the ratio. I can write the answer as a ratio. I.e., that is US $1 is equal to Barbados BD $1.98. This is unsigned right here, $1.98. That's it. So there are other ratio questions that are, you know, a little bit more, I don't want to say, a little bit more involved than these. But we'll do those questions as well, but we'll do them as ratio questions, all right? All right, but let's go. That ends question 1. It's just pretty straightforward and easy. All right, we don't need a calculator anymore. Well, not just yet. All right, this question wants us to simplify these now. And that's an indices question, right? So remember, a to the n times a to the m. You add the powers when the base is the same. That's how we're operating indices. And it becomes a to the n plus m. So here now we're multiplying these terms. And we're multiplying. This is a p term and that's a p term. The power on this p is 1 because it's not shown. So the power on it is 1. P to the 1 right here. So we'll focus firstly on the p to the 4th power, and the p becomes p to the 4th power. That's the 3 and the 1. And then now, the q now, we're going to multiply the q terms and add the power. This is 2 and 5. You add them. So you're going to get q to the 7th power. That's his answer. P to the 4th, q to the 7th power. Better good with that?
Yes, sir.
All right, good. Next question. Express this as a single fraction. Express as a single fraction in its simplest form. All right, so when you're adding fractions, guys, I know a lot of people do this and do 5 times 2 is 10 and put 10 on a year and say 5 divided by 10, 5 into 10 goes 2 times 8 is 2a, and that's right, 2a here. And then the 2 into 10 goes 5 times 3 is 15a. And then they add them and get 17a over 10. The problem with doing it this way is that a lot of persons just doing it by rote. They're doing it by a process. They don't really understand what is happening behind the scenes. All right? So I prefer to do it this way. We will learn and understand what is happening behind the scenes. So we can apply and interpret other questions later that are more involved. So these are what we call algebraic fractions. They are fractions with an algebraic expression here, which is a. When you're adding fractions, whether they are algebraic or numeric, you want the fractions to be related. Fractions are related when they have the same denominator. When fractions are related and you're adding them, the answer will have that same denominator, and you just add the numerator value, whether it be adding or subtracting. So right now they are not related because the denominator is different. So what I want to do is adjust this fraction and adjust this fraction so that they become related. So you want the two denominators to be the same. So a quick way to do it is to multiply this denominator on the numerator and the denominator here. Because normally you say you want the common denominator to be the lowest common multiple of the 5 and the 2. So that's going to be a 10. So you can multiply this 2 up here and down here, and multiply this 5 up here and down here. So like I'm multiplying this fraction by 2 over 2. So it's almost like I'm multiplying it by 1, 2 over 2. You multiply this fraction by 5 over 5. 5 over 5. So this denominator is going to become 10. That one also become 10. And so you have changed the appearance of these two fractions such that the denominator, they are related. They have the same denominator. So this one, the 2 times a is 2a over 5 2's is 10. And 2 times 5 is 10 plus. This one is 3a times 5. That becomes 15a over the 2 times 5 is 10. And then because they are now related with the same denominator, the answer will have that same denominator, and then you add the numerator values, which is 2a, this is 15a, which is 17a. So that is the answer, 17a. All right, I want us to practice doing it this way, adjusting fractions like that, because at a higher level, You'll have to be able to do these things comfortably with some with expressions. All right, so I want us to practice doing them like this. All right, practice doing them like that for me, please. That is the answer. But good at that?
Yes, sir.
All right, good.
Yes, sir.
All right, let's move on. This one wants us to factorize. And this one is kind of easy to factorize. Why? Because the only factors of this x squared is x and x. So I already know that the first values will be x and x. I know that already. This positive tells me that the two signs in the bracket are the same and that both of them are negative. Right? I remember now you need factors of this 4 to go here and there. And you want the factors of 4 must be such that the far product and the near product add to the middle term of negative 5x. So if I were to try 1 and 4, which are factors of this 4, then the near product would be 1x and the far product would be 4x. 1x and 4x is 5x, and that's what we have. But then we want them to be negative. As I said, the plus here means that two signs in the bracket are the same. And they are both negative because this is negative. So I know that I need a negative here and a negative there. And those are the two factors. That's doing it a quick shortcut method that I want everybody to learn. All right. But if you don't know it that way, let's move this up here. And you learn the process method. Then what it is, you want to break this quadratic out into 4 terms so you can factorize by parts. I mean, it kind of pains me to do it this in the other way, really, than to just observe that those are the factors. But let me just show you still. So I'm going to multiply the n coefficient. The coefficient of x squared is 1. And then multiply by that 4. 1 times 4 is 4. You want factors of 4 that add to the middle coefficient of negative 5. All right, now. Ready now. So this is a positive number. The 4 is positive. You want factors of a positive number. Factors of a positive number, it is either 2 positive numbers or 2 negative numbers. You want the sum of the factors of 4 to add to this negative 5 up here. And so we have to use 2 negative factors. So the first 2 negative factors of 4 that you will use will be 1 and 4. And you have to make both of them negative because both of them must have the same sign. And you want them to add to a negative number up here. So negative and negative. But negative 1 and negative 4 actually sum to negative 5. And so you have found 2 factors that you're going to split this negative 5x into. You're going to split it into negative 1x and negative 4x. All right? So then this expression, when you split out this middle term using these, you're going to get this stays as it is, x squared. Then it is the minus 1x, minus 1x. I can just put minus x, minus 4x. That's minus 4x. And then this plus 4 comes back out here, plus 4. I always check that what you split this into would give you back that middle term, which it would. All right, or which it does. Then you're going to do the highest common factor in these first 2 terms. Highest common factor in those 2 terms is x. So I factorize the x, and I get x minus 1 out of these 2 terms. Out of these 2 terms, I need to find the same factor of x minus 1. So what I normally do is put it back over here first. So I put in by the x minus 1 first. Then I need the factor that's going to go in between here. It's either a plus value or a minus value, not just a value. How you know what must go out there? You can divide this 4 by this negative 1. So 4 divided by negative 1 would be negative 4. So negative 4 go in between here. Or you can instead divide, okay? You can divide this negative 4x by the x. Negative 4x divided by x would leave me again with a negative 4 inside there. So I know that I need a negative 4 inside there. Let me erase these. So inside here, it's a -4. And if you're not sure, you can just expand this back across these brackets to get back these terms. So you can say -4 times x is -4x, and -4 times -1 is +4. And that's one of the reasons why I want to write down the two bracketed terms first. Whatever I have here, I put it back over here first, because some persons, in factorizing this part, might make a mistake and put a plus right here. And you must have the same thing in the two brackets. All right? So then, this becomes a common factor, and then you're adding these on the common factor, the x on the -4, so it becomes x minus 4 times x minus 1, which are the same two factors up here, just that they are switched around. So you have x minus 1, and x plus minus 4, x minus 4. So whether you write it like this, I write it like this, answer is the same. All right, that is it. But okay with that?
Yes, sir.
All right, let's continue. This one is to factorize these. When I see this, I'm thinking about the difference of two squares. When I see this, I see the squared term. That's a squared term really, because the 4 is the same as 2 squared. So this can be expressed as the difference of two squares. I can rewrite it as m squared minus 2n all squared, because I have the n squared and the 4 is same as 2 squared. So it can be written like this, difference of two squares. Then I apply the rule for the difference of two squares. Let's write it over here. It is that a squared minus b squared is equal to a minus b times a plus b. This is a rule for the difference of two squares that we're applying. So this is like our a, this is like our b. All right, so the difference of the numbers times the sum of the numbers. So it reduces to m minus 2n times m plus 2n. That is the answer right there. M minus 2n, m plus 2n. Right, okay with that?
Yes, sir.
Yes, sir.
All right, beautiful. Then here now they want us to solve. That's a linear inequality, a simple inequality to solve. Solving this inequality is the same steps that you would use if you're solving an equation. The only difference with the inequality is that if there comes a point where you have to multiply or divide by a negative number, you have to reverse the inequality sign. But the steps in solving this generally is the same steps in solving that. You're transposing everything away from the x to leave x as a subject. All right, so let's go through the steps. So it's really this for solving, and we're trying to make x a subject. So the first thing we're gonna do is move this -7. Move it over here and add it, or we say we'll add 7 to both sides. Still gonna get 2x less than or equal to 10, because the 7 come over here and add to the 3 to give me 10. Then we have to divide both sides by 2. Same thing we'll do with this now. We'll move the 7 over. All right? Then we have to divide both sides by 2. But because I'm dividing with a positive 2, there is no need to reverse this inequality sign. All right? Or we can say we'll divide the 2 under here. All right? So we divide. Let me write what we did. First, up here, we added 7 to both sides. Make it better. We added 7 to both sides to go from this to that. All right, plus 7. And then from here, we're going to divide by 2. So we're going to divide by 2 to go from this to this now. Where now, we'll divide this side by 2, we're going to get x. Sign stays the same because we're dividing with a positive number. Less than or equal to divide this by 2, we get 5. That's the answer. If you're solving this, the same steps, you would get x equals 5. All right? So this has an inequality on it. That is it. That's the answer right there. Next part says, if x is a positive integer, list the possible values of x. A positive integer, you know. What's a positive integer? An integer is a whole number. It can be positive or negative. negative, a whole number. All right. Now, if it is positive, it means that it starts at 1, then 2, then 3. But this is saying x has to be less than or equal to 5. So if we're to show this on a number line, just to help us, then 0, 1, 2, 3, 4, 5 is our critical value. We put a circle on the 5 and we would shade it. Why? Because the equal is there on the inequality, meaning that we're including the 5. Then you want values to the left. That is x less than or equal to 5, and that's a number line for x less than or equal to 5. If you want the positive integers to be 1, 2, 3, 4, and 5, you have to include the 5. If this was a less than sign alone, right here, then you would not include the 5, and you would have placed an unshaded circle on the 5 like that. All right, but this time the 5 is included. So let's go back. And so the values that we want are the ones that have circled in red. It says x is a positive integer. List the possible values of x. So x would be equal to 1, 2, 3, 4, or 5. Those would be a positive integer values. The whole number of values have to be it if x was a positive integer. But good with that?
Yes, sir.
All right.
Yes, sir.
I'm going to circle this and point to these red circles up there. Those are the positive integers. All right, let's continue down here. This one says find the value of 2 pi square root of L over G given these values. So it's almost another calculator question, listen up. Right? The 2 pi root L over G will be equal to, the pi is 3.14, 2 times 3.14 times the square root of the L, which is 0.625, 0.625 over the G, which is 10 over 10. This is what we're working out. Drop it in the calculator. Let's put it in the calculator. All right, let's work that out. So that is 2 times 3.14 times the square root of a fraction 0.625 over 10. So we're getting 1.57. That is the answer right here. 1.57. But okay with that?
Yes.
Yes, sir.
All right, good. So this question done again, 12 marks. Number 3, I think I said you have to do number 3B, right here. 3B. All right, so this question said diagram below not drawn to scale shows a parallelogram ABCD. It says, oh, I told it to the 3B. Yeah, not ready for 3B yet. If I did tell it to the 3B, sorry. Thought it was something else. I don't want you to have to construct anything as it, so forget about that. Or don't do it officially in the class as it, so skip over that one. Sorry about that. All right, number 4. It says an electrician charges a fixed fee for a visit plus an additional charge based on the length of time spent on the job. So when he goes there, before him start doing anything, he charges a fixed fee. And then now, in addition to that fixed fee, he charges, that's plus, he charges an additional charge that is based on the length of time. So there's a rate. It's a rate per hour, something like that. It says the total charge, Y, are calculated using this formula. So this must be the fixed charge. This must be the time, the X. And this must be the time for every hour, where X represents the time in hours spent, right? So X is the time spent. $75 is the fixed charge. 40 is the hourly rate. I'm multiplying 40 by the number of hours. All right, so $40 is the hourly rate. It says complete the table below for the equation, for this equation. So it's basically like, well, firstly, what will happen is that they keep adding 40 because you start out at 75 here. And then for every hour, you add in $40 more. So you can actually fill out this table by just adding 40 to this right here, adding 40 to this right here, right? Because you keep adding 40. Every hour you're multiplying by, you're adding 40 every hour. Or if you like, you can plug 2 in the formula and the 40 times 2 plus 75, for example, to get this value. But I'm just going to add the 40. That's, kind of easy. You realize you keep adding 40 every hour. So after 1 hour, this is the amount. You spend another hour, so you have to pay another $40. That's what it is. So you're adding 40 to this. So it is 155. If you notice, if I add another 40 to this, I'm going to get 195. So you see the consistency of it. Then now I'm adding another 40 to this. So if I add another 40 to this, I'm going to get what? 135. No, 235, sorry. Gone over 2 now. 235. And you can see if you add another 40 to this, you're going to get 275. If you add another 40, and if you add another 40 to this, you're going to get 315. So you see that you keep adding 40 because it's $40 every hour. And then question now says, on the grade on page 13, use a scale of 2 centimeters to represent 1 hour on x-axis and 2 centimeters to represent $50 on the y-axis. Plot the 7 pairs of values shown in your completed table. Draw a straight line graph. So basically drawing this graph, guys. So you must cross the y-axis at 70 and must have a gradient of 40. That's what it is, you're drawing that line. So over here we have to draw it. What scale did they say to use? They said to use a scale of 2 centimeters to 1 hour on x-axis and 2 centimeters to $50 on the y-axis. 2 centimeters. All right. 2 centimeters to 50. So we're gonna start it right down here. 2 centimeters to 1 hour. All right. So these are the 2 centimeter marks I'm putting on here. And it went up to what again? Went up to 6 hours, right? 0 to 6. All right, let's see if that works. So this is 0, 1, 2, 3, 4, 5, 6 actually stops here. This is the time. This is the x-axis. And the x-axis is the time. Time that is spent in hours. And on the y-axis is the amount that you spend every 2 centimeters is $50. So that's $50, $100, 50, 100. Look at the table. The table went up to what? We're trying to plot in the table, The table went up to 315. So, and every 2 centimeters, like I said, every 2 centimeters is $50. All right. So let's see. So it's $50, 2 centimeters, $100, 2 centimeters, $150, 2 centimeters again, that's $200. Then 2 centimeters again, another 50 is $250. 2 centimeters here is $300. And then 2 centimeters here is $350. And I think we don't need to go any further. We're going to label up this graph. And this is the amount of the fee, right? It's a fee. It's a fee. It's a fee. The amount paid. You see a fixed fee plus an additional charge. Total charge. All right, it says total charge. So this up here represents total charge. Total charge. and it's in dollars. All right, so that's our grid. So I want to know, especially down here, what each of these lines represent. I think each of them is 5 because there are 10 lines between 0 and 50. So you know the 50 divided by 10. So there are 10 lines there. I want to know what each line is. Total space is 50. There are 10 lines. 50 divided by 10 is 5. So each of these little small lines is 5. Okay. So you have to always recognize that for the small measurement. All right, let's look at the data now and put on the graph. All right, so these are our values. So when you can screenshot the values, I'm going to put them on the graph. All right. I'll take a picture with your phone or something where I don't want to be going back and forth. So it's 0.75. We're going to do 115, 2 155, 3 195, and that one, and this one, and this one. Let's go. All right. So the first value is 0.75. 0.75. I'm put it in red for you. All right. Yeah, let's put it in blue. This is 50. This is 75. So we're starting right here. 0.75. The next point, if you like now, you can draw a line. Can literally just draw a line now that has a gradient of 40 now. Rise 40, run 1. Right? So I keep adding 40. But the other point is going to be 1, 1, 115. 115 was the second value. 115. Okay, adding 40 to the 75. All right. So 115. 115 we need now on the here. So this is 100. What this is now 5, 10, 15. That is it. This line. 20, 25. So 115 is on this line right here. So this is the point. All right. Let's leave this as 115. The next point is 2. I add in 40 again. 2, 1, 5, 5. Add in 40 again. 155. That's right here. This is 150. 155 must be right here. That comes over the 2. This is the point. The next point was adding 40 again. So the point, you're gonna get 3, 195. 3 here, 195. 195 is right below the 200 on this line. So we're talking about right here. That's it. The next point is 4, 235. So we're looking for 4, 235 next. All right, let's see. So the 4 line here up here. So we're going for 235. So this is 225, 230, 235 is this line. So coming across on this line. 235 is here. Coming right here. So you see all these points line up on a straight line, right? But the question said to plot them, that's why I'm plotting all of them. Because I plot the first one and last one and draw the line, you know. But the question said plot the point, so I have to follow instructions. The next one is 5, 275. 5, 275. All right, next one was 5, 275. 5 here up to 275. 275 is this line. coming over to 5, which is this line. So talking about right here. All right, so that's it. Still falling on the straight line. And then the next one was added 40 more. Is 6, 6, 6, 3, 1, 5 for the last point. This is a 6th line. 3, 1, 5. So 300 here. 305, 10, 15. So it's 3, 1, 5. This line. So we know on this line here, right here. Right here. Alright, took a little bit longer than I needed, but I was drawing the first one. Maybe a good method would have been, since we know that straight line, put in the last one, put in the first one, draw the line, and then just mark these spots where the line intersect those hour marks here and here. But that is the line, guys. That is the line. Let me draw it through. This is the line, a straight line through here. If you use a ruler and do it, don't draw it free and line me. That is the line. All right, that's it. Draw it with a ruler, please. All right, what does it want us to do now? Next part, done. Just to draw the graph. Let's have some questions. Oh man, some questions on here. So draw the graph here, done. Next part says use the graph. So show that you're using the graph, or show lines on the graph to show that you use the graph. The total charge for 4.5 hours. Now I can calculate it, you know, by putting the 4.5 right here and what it is. So if I were you in the exam, I would calculate it to see what it is supposed to be, and then still work it until it gets it on the graph and make sure that they match. So it will be 440, times 4.5 plus 75. So it's supposed to be 255. So at 4.5, it's supposed to be 255. So let's look at it. So 4.5 is right here. Let's use the reading now. Right here. It's 4.5 hours right here. 4.5 hours. It's supposed to correspond. So you go up on the graph on this line. See? Right into the 255. You can see it. Come across and read it off this graph up here. One line about 250. That is 255 right here. So the answer here is $255. The charge is $255. But it's because the question says use a graph. You have to leave these lines that I've drawn, these red lines. Can't take them off, you have to leave them. So the examiner see how you use a graph. Next part says the time spent in hours for a job where the total charge is $300. So again, now you know the total charge and you want to find the time. So you can also work that out again, because remember 40x plus 75 is going to be equal to $300. So you can solve this for the x. So subtract the 75 and divide by the 40. So it will be 300, bracket 300 minus 75, close bracket, divided by 40. I'm supposed to get 5.6. You have to work with what you calculate, what the graph give you. You can't put 5.625 in the graph, not going to give you that. We're going to come on the graph at 300 on the y-axis and read it down to see what you get, which is 5.6. So we find 300 on the axis, which is right here. Right, come across on the graph. And you read it down. All right, I'm getting 5.57. And so that's 5.625 now, but I would give him the 5.7. That's what my graph gave me. You get me? Maybe you come a little bit closer. You can maybe, if you come a little bit closer, it's actually 5.55. Come a little bit closer. Look a little bit closer here. It's an our graph. It's right in between here and here, actually. All right, so 5.6 something real. Maybe I'll give him 5.65. Do it with the ruler, guys. Don't be friendly like me, please. So I'm reading it right here. This is 5.5. This is 5.6. This is 5.65. I'm going to write 5.65 instead. 5.65. Give the examiner that. Actual value is 5.625, but you have to use what the graph gave you. So I'm going to say 5.625. 5.65. 5.65 hours. Then say, what is the fixed charge? The fixed charge is $75. Obviously. It is a charge when x equals 0. When the x is equal to 0 and the time spent is equal to 0, you get the fixed charge. Put 0 in the formula right here for the x. You're going to get a $75 full charge. All right. And that ends that question. But okay with that?
Yes, sir.
All right. And this is, look at this part here. It says draw lines on your graph to show how the values are obtained. These are these lines, those red lines. If you don't put them on it, you're not gonna get the marks. All right, you're not gonna get the marks. All right, this question now is transformation as I see it. So the diagram below shows triangle LMN and the image PQR. So let's match up the letters first. Since I'm not using the prime and so on, let's match up the letters. So L is going to P, M is going to Q, N is going to R. Because the same order of the letters you have to use. All right. All right. So let's look at it now. It says what? Write down the coordinates of N. That's right here. That's 4, 5, 4, 5. So N is a 0.45. Next one. On the grid above, draw a triangle FGH. The reflection of LMN in the y-axis. All right, so it's FGH. LMN going to the same order. So note now that the L is going to F, the M is going to G, N is going to H. Reflecting in the y-axis. Could have said the line x equals 0. Y-axis is x equals 0. All right, so it is the LMN. That's one at the top, right? Reflecting this one over here. Read point by point. So it's LMN to FGH to FGH, reflecting in the y-axis. So here. All right, so the L first. The L is 2 units from the mirror line. So it's going to go 2 each on the other side here, right here. All right, so right here is the point F. Then M, it is 4 units from the mirror line. It's going to go 4 units on the other side to here. So that point is the second point, which is G. And then the N now is same 4. So it's going to go back over this one right here. And that point is FGH. And you draw the triangle. Do your reflection 1 point at a time. That is the image. Next part now says, it's a reflection. Next part says, use a vector notation. Use a vector to describe transformation which must LMN onto PQR. So LMN PQR. Good. So that's a translation, guys. The triangle just move down by what? Use 1 point to decide. Let's use this to this. How many units down? 1, 2, 3, 4, 5, 6 units down. All right, and no movement across. So see here, it's a translation. Given by, I can say a translation 6 units down. 6 units downwards. 6 units downwards. Given by. And that matrix is going to be the matrix 0, -6. That's the matrix. Okay. See a vector notation. That's a vector notation right there. Because only when 6 units down, 0 unit across. That is it. But I go to that.
Yes, sir.
All right. This one now says complete the following statements. PQR and FG. PQR is mapped onto FGH by combining two transformations. Let's look at it now. First, PQR is mapped onto LMN by let's look at it, PQR to LMN. So it's PQR to LMN. That's a translation, Let's go back 6 units upwards. So translation 6 units upwards, right? By a translation. Let's write this better. I want to say 6 units. So translation. Six units parallel to the y-axis as you go vertical upwards, parallel to the y-axis. It's a translation 6 units parallel to the y-axis. You can put positive 6 units, means that it goes upwards. Then the LMN is mapped onto FGH. That's this one now. Onto this one is the reflection in the y-axis, or line y(x = 0). Let's see. Followed by this onto this by a reflection in the y-axis. I just say in the line x = 0. Line x = 0 is the y-axis. That's it. It says PQR and FGH are congruent. Congruent shapes are equal in every way. State 2 reasons why they are congruent. Equal angles. The angles are equal. And the length of the sides are equal. Equal length of the sides. When shapes are equal, the angles are equal and the sides are equal in length. Right? Congruent. That's it. Congruent shapes. These are congruent triangles, equal in every way. I think we're skipping over this question. This question is a map scale question, you know, scale question. So to do it, you have to measure this up, right? So that's why I said skip it over. Skip over that one. Skip over this one as well, because I don't do circles yet, and this have some circle stuff in it. Statistics, don't do statistics yet either. Skipping that over for now. And we are moving down into this pattern question, which we're gonna do later on as well. Don't reach that yet. But we have done functions. So yes, we can do this one now. Number 9. So it gives us these two functions, f of x and g of x. It wants us to find f of 7, which is to plug 7 in the f function right there. So this becomes equal to 5 times 7 minus 4 over 3. So 5 times 7 is 35. 35 minus 4 is 31. 31 over 3. That's it. 35 minus 4 is 31. 31 over 3. That's it. Next question wants us to get an expression for f to the minus 1. So we're doing the inverse of this function. So we're going to start by saying f equals, what is it? 5x minus 4 over 3. We're going to inverse it first. The f which is range becomes the domain. 5 times this x, which is domain, becomes range in the inverse function, which is f to the minus 1. F to the minus 1. This comes back as negative 4 all over 3. We're now trying to make this a subject. So I've transposed everything away from it. First, we're going to do is multiply across here by 3 and get 3x equals 5f to the minus 1 minus 4. Let me shift this over. Then to make this a subject, we're gonna take the 4, add it over here, and then divide under the 5. So what we're gonna do, we're gonna get that 3x plus 4 over 5 is f to the minus 1. So we can say therefore, f to the minus 1, put in the of x now, is equal to 3x plus 4 over 5. That is it. F to the minus 1 of x. What good with that?
Yes, sir.
All right. Next part down there says write an expression for f of g. Remember, f of g means g into f. G into f. Let's set it up here. G into f. See it here? This is a g, this is a f. We are taking this entire g and we're gonna bring it and put it into the f. I'm using red ink for this. This is the entire g. The entire g, bring it and put it into the f where the x is right here. That's what we're doing. What are we going to, let's try what we're going to get. We're going to get 5 times the entire g, which is x squared minus 1, minus about the 4 over 3. I'm going to expand this and get 5x squared. 5 times minus 1 is negative 5. Negative 5 and negative 4 is negative 9 over 3. This is the answer. So let's copy all of this down. I'll cut and paste down here. That is it. So f of g of x is this, which is that. And that is it. Are you okay?
Yes, sir.
Yes, sir.
Yes, sir.
Beautiful. Then we'll come down here now, and I want us to complete the square. I spoke about this even in the session yesterday. So I kind of picked this paper because of some of the similarities of yesterday's work. So I want us to complete the square of this. That's what I mean by to write this in this form. But as I've always said, we are going to use a method where we use a into x minus the x value at the turning point, xt squared plus the y value at the turning point. What is the xt? We get xt from the coefficients up here. From this standard form, we can write out the coefficients. The a is the coefficient of the x squared, which is 3. The b is the coefficient of the x, which is plus 6. The c is a constant term, which is negative 2. We need xt go here. Let's work it out. So the xt that we want is minus b over 2a. Minus the b is 6. So it's minus 6 over 2 times a. The a is 3. This becomes a 6 now. So like 6 over 6 is 1. That's a negative 1. Since this is a whole number that we get, we're going to plug it back in the function to get the yt value. So we can say, and the yt value becomes 3 times negative 1 squared plus 6 times negative 1 minus 2. Yt value, that's yt value coming here. Now this is going to become 3. It's going to become negative 6 and negative 2. That's negative 8. 3 minus 8 is negative 5. So negative 5 is the value coming here for the yt. And so expression is that f of x is now equal to, if you're doing about this, the a is 3 bracket x minus a negative 1. Minus 1 becomes a plus 1. Don't forget the square, and you add in a yt, which is negative 5. That is it. I will stay with that.
Yes, sir. That's what I got.
Good. Then I want the minimum value, which is this constant. Just state it, negative 5. It is a yt value, which is the minimum value. Why about the turning point? This is the answer, negative 5 for that part. And just 1 mark. And it's just state it, eh? What else? State the equation of axis of symmetry. It is x equal whatever the xt value is. Xt value is what? Negative 1. Where are you? Negative 1. So it's x equal negative 1. This is the equation of the axis of symmetry. That's the answer. Axis of symmetry. X equal negative 1. Easy stuff. Sketch a graph showing the intercept with the y-axis and the minimum point. Now, first, the minimum point is xtyt, which is negative 1. What was it again? Negative 1, negative 5. xtyt, right? Negative 1, negative 5. Yes. The graph is going to have a smile shape, where the minimum point is this. And this is the y-axis intercept, which is a 0 c value. C value is negative 2. So that is 0, negative 2. That's what we're sketching. It's a smile shape graph because the A is positive. So that's a smile shape. All right. So let's sketch it now. Just a sketch, and don't have to be accurate. X-axis and y-axis. Let's sketch it in red. So it's gonna have a smile shape, right? But where does it turn? It turns at this point. Negative 1, negative 5. Negative 1, negative 5. Turn somewhere under here. Where does it cut the y-axis? At 0, negative 2. Negative 2 is somewhere on this y-axis. All right, so it turns down here and crosses y-axis down here. So I just need to draw a smile that does that, like this. So here would be our 0, negative 2, and here been minus 1, minus 5. Then the axis of symmetry, even though they didn't ask for it on the graph, so they're going to show it the vertical line through the turning point here. X equal negative 1. Axis of symmetry, x equal -1. That's a sketch, axis of symmetry. All right, that's all I wanted. I wanted the y-axis intercept and the turning point, and it smiles, turns down here. That's it. All right, everybody good?
Yes, sir.
Yes,
All
sir.
right, beautiful, beautiful. Then we come to this question, which is our Triggs question, sine rule and cosine rule. Once in section 2, that's what you'll have to use, sine rule and cosine rule. So we're going to read the information up here to see if everything that they're saying is on the diagram. Anything that's not on the diagram, we're going to put it on the diagram. All right. On the diagram below, on John's scale, RQ is 9, and it is in meters. No, it is in meters, 9 meters. RS is 12 meters, 12 meters. ST is 13 meters, 13 meters. The angle at QRS is 60 degrees right here. And angle SQT over here is 40 degrees. Now in this triangle, this one is not a right angle triangle, so we have to use sine rule or cosine rule. The one angle that we know, we don't know the opposite side to it. This is a typical case for the cosine rule. Angle between two sides. So cosine rule will find this side over here for us. Then in this triangle here now, we have an angle that we know and a side opposite that we know. So we can use sine rule, you know. But to go and use a sine rule, we need to know something else. Because remember, you have to know 3 things. And use a sine rule to find a 4th thing. If it's cosine rule, same thing. You know 3 things. So like here now, we know these 3 things. Cosine rule will find this side for us. All right. And then after we know this side, then we use this angle and this side along with this side. And then sine rule now can find something else, all right, in this triangle. But let's go, let's answer the question. First, I want the length of QS, which is this side. I'm going to work in this triangle and use cosine rule. All right, so let's tell the examiner cosine rule. Cosine rule for the QS. And it's going to be that the QS squared equals this side squared plus this side squared. Start like Pythagoras' theorem. But then it's not Pythagoras' theorem, so if you subtract a piece, it's cosine rule. You subtract twice this product of the 2 sides times the cosine of angle between them, which is 60 degrees. Instead of putting the square on here, I can take out the square and put the square root over this, which is what I wanted to do. Notice, not a lot of space to do a lot of work. So you can get it a lot quicker if you do it like this. Put this in the calculator, and the answer will be in meters. The distances are in meters. All right, let's put it in the calculator. So it's square root of 9 squared plus 12 squared minus 2 times 9 times 12 times cos of 60 degrees, which is a half. I'm getting 18.2. 18.2 meters. I'm going to work. It's meters, yes. 3 significant figures, that's the same. Then I want the measure of angle QTS. So let's go on it and put out, we now know this side. Put on the diagram as you find it. So this side I now know is 18.2 meters. So because I know these two, angle and side opposite, I can use this side to find the angle down here that I want in the sine rule with the sine rule, which is the angle that I want, angle QTS. Let's call it theta and put it on the diagram here as theta. So I'm going to use the sine rule for it, sine rule. All right, so I'm going to tell the examiner using the sine rule. Start with what you want, yes?
I think you did something wrong, sir, because in the calculator you put +2 instead of -2.
Thank you very much. Right. Beautiful. Like that. All right. I'm going to see what I had on it with a plus. If answer that makes sense. Yeah, 18, it kind of makes sense in terms of the size of the numbers, right? That's why I can accept the 9, 18 something, but it should be a minus. All right, thanks for that. So it's supposed to be a minus, not a plus. All right, so it's actually 10.8. Beautiful. All right, 10.8. All right, very good. That's what happens when you do the work. And make a mistake, you will see it. All right, so 10.8. All right, 10.8. 10.8. All right, thank you so much for that. Very good. All right, that's what happens when you do the work. All right, so we're going to use the sine rule now, right? So it's going to be the sine of the angle that we want over the side opposite to it, which is the 10.8, equals sine of the angle that you know, which is the 40 degrees up here, over the side opposite to it, which is the 13. That's what we're going to solve for the theta now. So the first step will be to multiply the 10.8 up here and then take the inverse sine of that result to get the theta. So the theta is going to be sine to the minus 1 of the 10.8 is going to be up here. 10.8 times the sine of 40 degrees divided by the 13. So this is what we need to put in the calculator now. And put the answer right here. It's an angle in degrees. All right, let's go. So it's sine to the minus 1, bracket, a fraction, 10.8 times the sine of 40 degrees over 13. We're getting 32.3 degrees. 32.3 degrees. When in doubt, three significant figures. If it's angles in degrees, you give it to one decimal place. When in doubt, for the level of accuracy, since they did not tell you how accurate, you must give your answer. That is it. All right. Very good. Very good. Very good. I like that somebody's seeing the mistakes and getting it right. Area of the triangle QRS. That's this triangle right here. So in this way now, we can use the method where we have two sides and an angle between. We're going to use a trig formula for the area of a triangle. So yesterday's paper had one like this as well. So remember now what we have is the two sides, the 60 degrees. All right, and the sides are 9 and 12. 9 and 12 meters. Using the formula half AB sine C. This is the A and the B, and the C is angle 60 degrees. So the area becomes half the 9 times the 12 times the sine of the 60 degrees. All right, let's work that out. So it's 0.5 times the 9 times the 12 times the sine of 60 degrees. I'm getting 46.8. If I corrected three significant figures, 46.8, and has to be meters squared. That's the area of that triangle. The next part now says we have to calculate the perpendicular distance from Q to RS. I like this question a lot. The perpendicular distance from point Q to RS. Let's show that distance on the diagram. Perpendicular distance from Q to RS. I'll show you how that becomes relevant. Let me take these out. So that question is talking about, let me write this 10.8 differently here. This 10.8, let me write it differently. Let me put it like this, 10.8. Let me write it over here instead. 10.8 meters. We're talking about this length, right? The distance that I want, perpendicular distance from Q down to RS. So we're talking about this. This distance I want, you know. Let's call it H. So it's like it is like the height of the triangle if you have this as the base. All right. All right. So how can we find this H now? We can find it two ways actually. If you zoom it up, we can come and recognize this now as a right angle triangle right here. Let me mark it out in blue for you. Like we can recognize this as a right angle triangle. So we can use so-called tower in it. Let me put the H on the other side over here. Let's put it out here. And like we're trying to find that height in this right angle triangle. Put right angle here instead. So like we're working in that blue triangle now. We have this 60-degree angle, sorry. And this is the hypotenuse. And so we can use sine equal sine. This is the opposite that we want, and that's hypotenuse. So we can say sine of 60 degrees equals the hypotenuse, or the opposite, sorry, over the hypotenuse of 9. Take this hypotenuse and multiply it up here. And so the H would be 9 sine 60 degrees. And therefore the height that I want will be 9 times the sine of 60 degrees. Let's see. 9 times the sine of 60. And that will be 7.79. 7.79 meters. That's what I'm getting. Let's copy this down. Present this as an answer. Copy. Anybody got that? Anybody did it and got that?
Yes, sir.
You got it? You got it? That's what they said. You got it?
Yes, sir. Yes, sir.
Beautiful. All right, let me show you another way though. Since we know the area is this, right? If you look at it as the area now of the triangle is half this base times this perpendicular height, and you know the area is actually this area that we calculated a while ago. Supposed to get the same answer. So know that the area will be equal to half the base would be this 12 times this height. So it'll be half 12 times the height will be equal to this area of 46.8. That's what the area is equal to, you know. Let me take this out. So actually working here now. Half 12 times the height, perpendicular height equals 46.8, the same area. This is 6. So it means that 6H is equal to 46.8. Divide by the 6. So the H is equal to 46.8 over 6. So the H equals, supposed to get the same thing. 46.8 divided by 6. See, 7.8. Because we corrected this to these figures, we're getting 7.8 meters, which is the same 7.8 that this is really, if you correct it to small places. Let's make this larger. So you could have done it another way with the area. See that? More maths equals better maths every time. See that, guys? So
Yes,
you could
sir.
have done it this way, recognizing the triangle and recognizing the right angle triangle, or could have used the area that we have, recognizing that this perpendicular height, this distance that I wanted, became the perpendicular height in this triangle if you treat this as the base. So we could relate it to the area, half base times height that we had. And this is the area that we know. And we could do it that way. The same answer. All right, let's go. Next question. We are on, I think it's the last question. No, the vectors. No, we have number 11, part A. Or it's matrices and vectors, and then we're done. All right. Yeah, let's do this now. Don't think I need the calculator now. Let's do this. Let's do this. All right. Question says we have to write these as a pair of simultaneous equations, and I want us to write it as a matrices equation. So we have x followed by y here, x followed by y here. So we're good to go. It becomes a 2 by 2 matrix times the column matrix. Let's write it better. 2 by 2 matrix times the column matrix xy equals a column matrix with these values, negative 1, 6. And they put in the coefficients inside here. So it is 3, 2, everything positive, 5, 4, positive. That's a matrices equation. So this is like the A. This is like the X. And this is like the P. And that's a matrices equation. 2 marks for that. It says use a matrix method to solve it. So you're trying to find the XY. So you take the inverse of this in front here. Remember, this is on the front. The inverse goes back on the front. And they leave this as a subject. So the xy, see, you don't have a lot of space to work with. Some space. Okay, I have some space. The xy is going to be equal to the inverse of this in front here. Let's write it like this. 3, 2, 5, 4 to the minus 1. The inverse of it, let me put that minus 1 in red. So it stand out. Change the color to red. Everything I want to change to red. Let's do it again. Good. So I'm putting the inverse of this matrix in front here. In front of the negative 1, 6. So I need to calculate the inverse of this matrix now and do this calculation until we're finished. Inverse of this matrix is 1 over the determinant. What's the determinant? This product, which is 12, minus this product, which is 10. Multiply that by the adjoint of this matrix. So we do the adjoint. Interchange the elements on that first diagonal. Switch them around. 4, 3. Leave these two where they are and change the sign. So this becomes a negative 2. And this becomes a negative 5. This is just the inverse we have so far now. And then we multiply that again by the negative 1, 6. And this becomes a 2 under here, but I usually leave that for last. I put 1 over 2. And I will actually multiply this out. And get a column matrix. We multiply this out, right? So multiply that by taking the rows of this first matrix. Multiply by this one column. So we're going to get these two values. So how do we get this first value? It is the first row times the one column. So multiply this first row by this one column to get this value. How we do it? First element times first element. Second element times second element to get this value. First element times first element. First element times first element. Second element times second element. 4 times negative 1 and negative 2 times 6. 4 times negative 1 is negative 4. And negative 2 times 6 is negative 12. Then the value down here now, it is in the second row and the one column. So multiplying this second row with the one column. Multiply the same way again. First element times first element. Second element times second element. Negative 5 times negative 1. And 3 times 6. Negative 5 times negative 1 is a positive 5. And the 3 times 6 is 18. 6 3s are 18. Don't really like these values. Let's see. Make sure. Negative 1. I'm done. I'm going to check the answers. All right. So this becomes negative 16. Negative 16. You can divide it by the 2 same time and get negative 8. Let's write it. This is negative 8. This becomes what? 23. 23 over 2 is 23 over 2. 23 over 2. Or maybe 11.5. I don't like these values, but I'm going to test them. That's xy. And so the x is equal to this, and the y is equal to that. So I'm going to write the x equals -8, and the y equals 23 over 2. I don't like these answers. I'm just going to make sure that they are correct, right? -8. All right, let's make it a calculator and let's test them. Make sure they are correct. Let's test them in the calculator quick and fast. So we say the x equals -8 and y equals 23 over 2. All right. Let me write it now. It's 3 times -8 and then you add in 23 times plus 23. Yep, -1. That's correct. Let's try it on the second equation now. It is 5 times the -8. 5 times -8. And then you're adding 4 times 25 over 2, 23 over 2, -6. Yes, so those answers are correct. -8 and 23 over 2. Didn't like them, but you know, those are the correct answers right here. Just tested them. That's correct. Everybody good with that?
Yes,
Yes,
sir.
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 All right, good. Then we'll come to the vectors now. Vectors give us these two vectors, OR and OS as position vectors. These are the points. Those are the points. And so they want us to write down OR. If the coordinates of R is 6, 2, then the position vector will have the same values, 6, 2, as column vectors, OR. OS similarly will have the same values as the coordinates, -4, 3. Easy like that. Then, oh, they have it here as well. Oh, okay. So let's put them right there then. So the OR will have the same coordinates as the point, 6, 2. And OS will be -4, 3, having the same coordinates as S. No calculation needed. Then I want SR. So SR, you can look at the diagram and actually see how you go from S to R. So how many units this way, and then 1 down, right? So how many units there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 units to the right, and 1 down. That's 10, -1. That's what I'm supposed to get. 10, -1. All right, so the graph is telling me it's 10, -1. Let's do it by calculation now and see if we get the same thing. So SR is O times the last, O times the last, this is the last, minus O times the first, OS. The OR, remember, is 6, 2, minus the OS is -4, 3. So 6 minus becomes a plus. 6 plus 4 is 10. And 2 minus 3 is -1. Good. So I can be happy with that answer because it corresponds with what the graph is showing me. 10 to the right, 1 down. That's what I love about vectors. What you get by calculation must match what you have on a diagram. I like vectors questions with a diagram. So you know that you're correct. All right, you're certain about this answer. Down here, it wants the modulus of OS. The modulus is the length. So again, you can look at the vector OS, which is this line. And if you look at the components of it, it is this length to this length. This is 4 units. This is 3 units. That's a 3, 4, 5 triangle. The answer for this is 5. This is 5 units long. So the answer for this length is 5 units. All right? That's a 3, 4, 5 triangle we have. But if I use the vectors method to show the work down here, these are the coordinates of OS, you know. Negative 4, 3. That's a vector. So the modulus of OS becomes the square root because it's really Pythagoras' theorem. Remember the OS is negative 4, 3. Negative 4, 3. So the square root of this value square, but I don't need to put the negative. I just put 4 squared because that's really one side of the triangle. Plus the 3 squared. It becomes 5 units long. And the graph is showing me the same thing. 5 units long. Easy. 1 mark. So that's so easy. Next one. It says OT is they should put an arrow on top here. It's a vector. OT is 2, 5. It means that T is a point 2, 5. All right. Prove that OSTR is a parallelogram. All right. So we have to show that it satisfies the property of a parallelogram, which is that it has 2 pairs of equal opposite parallel sides. So if it's a parallelogram, the opposite sides are equal vectors because equal vectors are parallel with the same length. So the opposite sides of this parallelogram must be equal vectors. Let's get the orientation right. We can actually put on the diagram and see it, you know, the point 2, 5. So you can actually see what you're working with. So 2, 5, 2, 5, 1, 2, 3, 4, 5. So it's actually up here, this point up here. That's where T is located, all right? That point here. So T is right here. So if I complete the parallelogram like this, and I'm seeing what I'm working with, then basically what we're saying is that this vector on this side must be equal to this vector on this side. This vector on this side is OR. It must be equal to the vector on this side, which is ST. So we're going to have to show that ST is equal to OR. And then the vector on this side must be equal to the vector on this side, which is RT. So this vector on this side is OS. It must be equal to the vector on this side, which is RT. So we have to show that it's a parallelogram. Let's write up here. We need to show that the ST is equal to OR. ST is equal to what OR is. And that RT is equal to OS. RT is equal to OS. That's what we need to show it's a parallelogram. Let's copy this down. So telling the examiner how we're going to show that it's a parallelogram. So here, let's put it here. That's what we're required to show. So we need to calculate ST, show that it is OR, calculate RT, show it is OS. Let's do it now. So tell them what we need to show. So what is the ST? The ST is OT minus OS. The OT is 2, 5 minus, what is the OS again? Let's see. I don't remember. The OS is negative 4, 3. So subtracting negative 4, 3. We work this out. 2 minus a plus, that gives you 6. 5 minus 3 is 2. Remember, this is ST now. Remember that the OR is actually 6, 2. See it up here. The OR is actually 6, 2. So that part of it is shown, right? So I've concluded that ST is equal to OR. So finish the first part here. We need to show this part now. Let's do it here. The RT now. The RT is actually OT minus OR. The OT again is 2.5. And the OR is the same 6.2. And this works out to be 2 minus 6, which is -4. And 5 minus 2 is 3. And the -4, 3 is actually OS. -4, 3, sorry, is actually OS. So we have now shown that the RT is equal to OS. So we have now shown this part. So this part is shown, that part is shown. And we're telling that's what we need to show. So we can draw the conclusion and say, therefore, OSTR is indeed a parallelogram. Done. Very good.
Yes, sir.
Yes, sir.
Somebody said no.
Yes, sir.
Who's not good? Somebody said no. Somebody said no. I heard a no. All right, guys. That is it for today. You know the drill. I want you to go and redo the questions. Those of you who did not do it at all, you need to go and do it. I'm going to share the video right away. Use the video to help you to go back through. Those of you who did, made a mistake here or there, you need to redo the questions. Redo the questions. We need to master these things. All right. I don't know if you're gonna have another class before the new year. If you don't, I wish you a happy new year. Happy new year. We're gonna be doing a lot of work in the new year because we have to work to get those distinctions. All right. So it's gonna be a lot of work, especially from March. We still have a few things to learn, and we'll be revising as we learn new stuff. But we're gonna really increase the intensity. And those of you who are not as serious as you're supposed to be as yet, you need to get serious right now. Don't allow any more gaps to creep into your knowledge. Everything that we do, we need to be on par with what we're doing in class going forward. Yes, you might have missed out on a couple stuff here or there. We're going to be revising everything that we have done. All right, as we go, we're going to be revising. But anything that we do new now, we don't need any more gaps. You need to learn them properly by doing the right things, doing what I tell you. All right, you need to practice, do everything that I tell you. All the questions that we do in class, you need to go and redo those questions. When we get to March, you're going to be getting a lot of questions to do on your own. You're going to be doing questions before I do them in class. We're going to be doing a lot of mock exams and sharpening up for the exam. All right, so you need to get serious right away. So we'll start in January, kicking on for the exam. All right, this is doable, guys. This can be done. The distinction is there for you to get. Straight A profile is there waiting for you. It is not beyond any of you. You just need to just do the right thing. Practice. Follow my instructions to the T, and you'll be good. All right, let's just come prepared to do a lot of work. When I give you the work to do, about a frown and say, boy, sorry, so much of this. It is what is required. I'm going to give you what you need to do. I'm going to give you what is required. All right, and the harder you work,
Yes, sir.
the harder you work is the harder I'll work as well. So put in the work, and I'll be there with you. And don't be afraid to reach out. Let me know, any area that you're not understanding, anything that is not so clear. You can reach out to me one away, and we'll sort it out. All right, guys. So have a good one. Enjoy the rest of this year. And I'm really looking forward to next year because I know I'm going to get a lot of distinction from this class. I just know it. You agree?
Yes, sir. Bye.
Yes, sir. Yes, sir.
All right, good. Looking forward. All right, bye, everybody. I'll let you know if you have any class on Sunday. I'll let you know. I will let you know. All right? All right, bye. I'm in the session now.